Hi everyone, welcome. First of all, in this video, there is the basic mathematics video. In this video, we are going to discuss about the series and sequence. Okay, question on series and sequence. In the last basic mathematics class, we have discussed about straight lines. Okay, that question is regarding straight lines. This question is regarding series and sequence. Okay, and this topic is important for BARC as well as csirnet, right? So this is useful for csirnet aspirants also, right? Okay, we will see. First of all, evaluate summation of p equal to 1 to infinity. Limit is p equal to 1 to infinity, and you have to evaluate this equation. So how you can evaluate this equation? That is the important thing. In this equation, you have to find out s infinity term, right? So first of all, you have to calculate one equation. From that equation, you have to calculate the terms. You have to add those terms, then you will get s infinity term. So I will tell you how to do this question. First of all, given this equation, in this equation, if you see here, p is there, here root p is there. I can write this p as root p whole square or root p into root p. Why? So root p into root p, that means root p whole square. Square root get cancelled, again I will get p. Okay, here root p plus 1 is there, here p plus 1 is there. How can I write this p plus 1? So root p plus 1 into root p plus 1, that means root p plus 1 whole square. Square root get cancelled, p plus 1 again. So I can write p and p plus 1 as, first of all, I am writing like this: 1 by root p into root p plus 1, right? Plus, in place of p plus 1, I am writing root p plus 1 into root p. Okay, so I modified this equation like this. Okay, this is the first step. Second, here root p is there, so I'm just here root p 2 times, here root p plus 1 2 times. I'm just taking common. Okay, if I take common, if I take root p as common, so 1 by root p here, 1 by root p here, here root p is there, here root p is there. Okay, here root p plus 1 is there, here root p plus 1 is there. So 1 by root p into root p plus 1. What remains? Here root p, so 1 root p is there still. So here 1 root p plus 1 is there still. So I can write 1 by root p plus 1 plus root p. Clear or not? Okay, so I'm just taking common. I'm just taking root p as common and root p plus 1 as common. So if I take common, then what happens? Here 2 root p's. So 1 root p is just outside. Now root p is there. Here root p plus 1 is there. So root p plus 1 plus root p. I can write this equation. So whenever we have roots, this is a rationalized equation. You have to rationalize this with minus sign. If you have the plus here, you have to rationalize this with minus. How you can rationalize? See. So root p plus 1 minus root p. Okay, with minus sign you have to rationalize by root p plus 1 minus root p. You have to write like this, right? Because you have in the denominator you have like this, so you have to take minus, just opposite to this. Now what happens? Here this term is there already, so 1 by root p into root p plus 1. Okay, next, here root p plus 1 minus root p plus 1 minus root p over a plus b into a minus b. A square minus b square, a square minus b square, root p plus 1 whole square, square root get cancelled, p plus 1. Okay, so next p plus 1. Next, a square minus b square, root p into root p. So p get cancelled. I am getting here 1. So overall equation is root p plus 1 minus root p over here root p into root p plus 1. Acha. Now I can write this one as root p plus 1 over this, right? Root p plus 1 over this, root p plus 1 get cancelled. So 1 by root p minus root p over root p into root p plus 1. Root p get cancelled, root p plus 1. So 1 by root p plus 1. So final equation is this. Final equation is this. Okay, I'm just removing everything here. Now I got the final equation. This is, by using this equation you have to find out the term Tn. Okay, 1 by root p minus 1 by root p plus 1. Okay, you have to use this equation finally. Then you have to first calculate first term T1. Here limit is 1 to infinity. First of all, in place of p put 1, so 1 by root 1 minus 1 by 1 plus 1 2, so root 2. This is the first term. Second term T2, 1 by put 2, up to infinity you have to put, right? 1 by root 2 minus 1 by root 3, right? So calculate up to infinity. Okay, so up to infinity you have to calculate. What happens? You have to add these terms. If you add these terms, 1 by root 2 get cancelled. Here 1 by root 3, here 1 by root 3 get cancelled. Okay, finally if you get here 1 by infinity, so 1 by infinity means 0, that means no value. Up to infinity only you have to do. So if you do this, if you add these terms like this, everyone will get cancelled and finally you will have only 1 by root 1, that means 1. So S infinity is 1. Clear? So this is how you have to do this type of questions. Okay, like this you have to do this type of questions. This is regarding series and sequence. Okay, practice, if you can practice more questions, okay, on this topic. Okay, so that's all. Thank you so much.